Now I would like to discuss with you one problem where we will explain how to get the polar form of a complex number. Convert the complex number minus 16 upon 1 plus iota root 3 into the polar form. So first of all, I will say it is given by z is equals to minus 16 upon 1 plus iota root 3. Very first step here required is to get rationalized, or in the term you can say multiply numerator and denominator both of this complex number by the conjugate of denominator, that is by 1 minus iota root 3 in numerator and 1 minus iota root 3 in denominator. If I will do so, I will get it is minus 16 into 1 minus iota root 3 upon. This is a plus b, it is a minus b. The identity become what? It is a plus b, a minus b, a square minus b square. So this become 1 square minus root 3 iota whole square. So this complex number z is coming or turning in the shape of minus 16 times of 1 minus iota root 3 upon, this is 3 iota square is minus 1, so this will become plus 3 and plus 1 become 4. And when this 4 is allowed to divide minus 16, this will give us minus 4, and when minus 4 multiplied with 1, it gives us minus 4, and minus 4 into minus, this gives us 4 root 3 iota. So our complex number net exact form, that is z is equals to minus 4 plus 4 root 3 iota, is the pure x plus iy form. First of all, what we did, we have converted the complex number in its standard form x plus iy. If I compare it with x plus iy, I will notice the answer of x is minus 4 and y is 4 root 3. So basically first I need to calculate the r. This is real part square plus imaginary part square. Real part is minus 4, its whole square is 16. Imaginary part is 4 root 3, its whole square is what? 4 4 is 16, 3 is 48. So if we add it, we will get 6 plus 8, 14, 4 plus 1 minus 6, that is coming out to be 8. So the modulus of this complex number is coming 8. Now we want to find the argument. To find the argument, we will go to calculate, say for example tan alpha mod of y upon x. Y is 4 root 3, x is minus 4, which is giving us root of 3, which implies the value of alpha in the tan at root 3 is coming out to be pi by 3. Now important task is, if alpha is pi by 3, we should try to diagnose that this complex number whose standard form is minus 4 plus 4 root 3 iota is in which quadrant? X is negative, y is positive, it is in the second quadrant. So I can say its argument will be pi minus theta, because in second quadrant. Pi minus theta, or you can say pi minus alpha. So alpha is pi by 3. So pi minus pi by 3, its argument become pi minus pi by 3, that is what? 2 pi by 3. So the net formula for writing the complex number in the polar form, as explained you, z is equals to r into cos theta plus iota sin theta. Here theta means argument, that is what? 2 pi by 3. So z is equals to r. What is our r? That is modulus is what? 8. Answer become 8 into cos of argument 2 pi by 3 plus iota sin 2 pi by 3 is the polar form of this complex number.